In the last lecture, we just discussed the remaining portion of the probability and solved 2-3 questions. Now we'll proceed further with the practice. Okay, just solve this question now. Just take 1.5 minutes and try to solve this. Then we'll discuss this question. And I want all of you to solve this so that we can have an interactive session. Okay, let's solve. A. So someone is saying A.
E for delta.
For delta. Any other answer? 1/10. Yes, so 2 answers for D. Anyone is still solving, or shall I solve now? Okay, so let's solve. In this question, there is a statement that we have a box with 10 balls, numbered 1 to 10. If a person remove a ball at random and afterward replace that ball, and then the other person removed a ball at random, so what is the probability that both person remove the same ball? So let's try to solve this question. So what is the probability of picking a first ball, right? So what is probability favorable outcome of a total outcome? So in total we have 10, and for the first ball, the person can pick any ball out of 10. So right, for the first, there will be 10/10, right? So out of 10, the person can pick any 10 balls numbered from 1 to 10. Now the situation is based on the first, that the second person need to pick same ball, right? So let's suppose the person picked a ball with number 2 on that. So for the second person to pick same ball, there's only one option remaining, and as the person replaced the ball, that's mean the total remains same. That's why the answer to this is 1/10. The first one is for picking the first ball, so there are 10 options for that, and for the second, he can pick the same ball which is removed earlier and replaced. So there is one option for that, and the person replaced the ball. That's why the total remains same. So this is 1/10. That's why the answer is D. Perfect. Okay, let's try this question now. And try to be quick. So can you tell what is the answer to this question?
B for beta.
B for beta. Anyone else solve this question? Or tell me one thing, what is happening in this question? Anyone who can explain?
Yeah, so it's a random variable that takes the value 3x by y. For x equal to 1, it will be 3 by y because x equal to 1. And for x equal to 2, it will be 6 by y because x equal to 2. And so similarly for x equal to 6, it will be
Tell me
18.
one thing, is this fair dice or unfair?
It's unfair. Fair dice will always have 1 by 6.
Exactly. In the fair dice, the probability of each of the number from 1 through 6, that will be 1 by 6 for all, for any number from 1 to 6. But for unfair dice, that depend upon the condition provided. And the question is saying that a dice is numbered from 1 through 6 through mean 6 and 1 both are included, right? This is a second, you can also call this as inclusive. True and inclusivity, same thing, right? That's why 6 and 1 both are included. And when the dice is rolled, the probability that the number x will appear on the top, right? So dice x will be 1, 2, 3, 4, 5, and 6, right? Because there are 6 options variable on the top, which is equal to 3x by y. Now when x is equal to 1, so what is the probability? That will be 3 into 1 divided by y, which is 3 by y. When x is equal to 2, 3, 4, 5, and 6. So this will be 6 by y, 9 by y, 12 by y, 15 by y, by y, and 18 by y, right? Now the next thing is, you must know that the sum of probabilities, all of the probability of each of your must equal to 1. There are only 6 options available, and sum of all these 6 must equal to 1, right? So 3 over y plus 6 over y plus 9 over y plus 12 over y plus 15 over y plus 18 over y is equal to how much? 1. So just take the LCM, this will be y. So just sum above all of these, 3 plus 6 plus 9 plus 12 plus 15 plus 18 is equal to y. So what is the answer? If someone asks you quickly, sum this series, how can you sum this in a quick way?
3 into 1 plus dot dot 6. So 3 into n into 6 into 7 by 2.
First of all, this is in arithmetic progression, right? Because a common difference of 3 in each, plus 3 plus 3 plus 3 plus 3. Can anyone else tell how we can find the sum of this series if the series in arithmetic progression?
We can use the formula n by 2 2a plus n minus 1d, wherein the total n is 6 and d is the common difference is 3.
Yes, you can do this.
So
Or you can also do this way, n over 2 into first term plus last term. What is the first term? 3. What is the last term?
3.
18.
18.
So what is the total number? 6. So 6 by 2 into 21. So this will be how much? 63. You can do this way, or you can do this way. What is the average? Average is equal to sum by total number. So if this is in arithmetic progression, the average is equal to the median. So what is the median in this case? That will be how much? 10.5, right? Because total number are even, and for even the average will be just the average of the middle two terms. So 9 plus 12 divided by 2, this is 10.5. So 10.5 is equal to sum divided by 6. So this sum will be equal to 63. So you can proceed by any way, this formula, or by this way. Or you can even add whatever you prefer. It's a very simple question, you can solve it. Yeah, try this question and try to be quick. Okay, so what is the answer?
D for delta.
D for delta. Any other answer? No one else is solving it except you. No one is even responding. Shall I solve now, or anyone is still solving? So one person is saying, hey. Okay. So the question is saying a fair coin. First of all, this is fair. That's mean, and this is a coin. There are two options, head and tail. So the equal probability for head and tail. So that will be 1 by 2 for head and 1 by 2 for tail. Tossed 4 times. Okay, a fair coin is tossed 4 times. What is the probability of getting at least 2 tails? This word is very important, at least. So there's a minimum of 2 tails and then 3 tails and then 4 tails. Okay, so in this question, we're asked to find the condition for at least 2 tails. So we can do 2 ways. Either we can proceed by solving 2 tails, 3 tails, or 4 tails, or we can solve the inverse. We will see the condition in which there is less than 2 tails, either no tail or either 1 tail. So let's see the inverse condition. First condition is when there is only 1 tail and when there is no tail. So when there is 1 tail, that's mean we have 3 heads and 1 tail, and when there is no tail, that's when we have all of the 4 as heads. So how can we find the probability of getting 3 heads and 1 tail? So what is the probability of head? 1 by 2, next head 1 by 2, next head 1 by 2, and the tail 1 by 2. Now we need to arrange this. If you remember the Mississippi rule, this can be arranged in 4 factorial ways, and we'll divide with 3 factorial because there are 3 identical edges, 3 factorial and 1 factorial. So this will be 1 by 16 into 4 factorial, 4 into 3 factorial divided by 3 factorial. So this is equal to 4 by 16, which is 1 by 4. And if I did anything wrong, please let me know. And what is for this? This will be for first edge 1 by 2, 1 by 2, 1 by 2, and 1 by 2. And all of these are identical. So it doesn't matter. Either I put this h at first or the third one h at first. And if I use the Mississippi rule, that will be 4 factorial divided by 4 factorial. Right? So this will be just equal to 1 by 16. So now, as I consider the inverse case, so what is the required probability? That will be total probability minus the restricted cases. Total probability is always equal to 1, and the restricted case, we have to 1 over 4 plus 1 by 16. Okay, so this will be 1 minus, to make the basis common, let's multiply first one with 4. This will be 4 by 16 plus 1 by 16. This will be equal to 1 minus, just to make difference, 1 minus 5 by 16, which is equal to 16 minus 5 by 16, and this came out to be 11 by 16. Right? This is the inverse method in which I just subtract the restricted cases out of total so that I can get the required cases. And if you want me to proceed with by finding the condition for 2 tails, 3 tails, and 4 tails, please let me know if anyone of you want me to solve that way as well. Anyone who want me to solve that way? Binomial way? Okay. Binomial is exactly same thing which we did this. That is NCR into the probability of success power R into probability of failure power n minus R. So if I consider, first of all, let me, how should I solve this? By the restricted case or by finding all of these? Just let me know. Okay, let's solve this by restricted case, because there is one less calculation in which we are getting 1 tail and no tail. So 1 tail we have 3 heads, and 1 tail and no tail we have all of these heads. Now see the first scenario, which is 1 tail. If I consider tail as our success case, and the head is our failure case. So that's mean by using this formula, what will be n? N will be equal to 4. What will be r? Because we are considering tail as a success and we have only one tail, that's why r will be equal to 1, and n minus r will be equal to 3, and probability of success, it is equal to the probability of tail is equal to 1 by 2, and probability of failure will also equal to probability of heads is equal to 1 by 2. Now if we use the formula, so that will be simple, 4c1 into 1 by 2 power 1 into 1 by 2 power 3. So that will be 4 divided by 2 power 4, which is 4 by 16. This is the first scenario in which we are having only one tail, right? Should I move forward to the other scenario in which we have no tail? Okay, so now other scenario in which I have no tail. So that's mean we have all of these 4 as a head. Now in this scenario, n is using this formula, NCR into probability of success power r into probability of failure power n minus r. So n is equal to 4 because we have total of 4 trials. Now if it depends whether I consider probability of success as head or tail, doesn't matter, you will get the same answer, right? I am considering the success as head and failure as tail. So the probability of success will be equal to 1 by 2 and probability of failure will also be equal to 1 by 2. And its probability of, I'm considering success as a head. So that's why r will be equal to 4 and n minus r will be equal to 0, right? So if I use the formula 4, okay. So we have 4c 4 into 1 by 2 power 4 into 1 by 2 power 0. So that will be 4c4 will be equal to 1 into 1 by 2 power 4, which is 1 by 16, right? So now, yes, answer is 11 by 16. Now I have both of the restricted cases probability. So that is 4 by 16 plus 1 by 16, which is 5 by 16. Now to find the favorable outcomes probability, that will be 1 minus 5 by 16, which is 11 by 16. So either you can solve with that method or you can use the binomial probability, you will get the same answer. Solve this question now. This is a very interesting question. Okay, when an unfair coin, right? So that's mean the probability of head and tail will not be equal. It's tossed twice. The probability of getting one tail and one head. So probability of getting one head and one tail is equal to 1 by 3. But you need to consider two cases in which we have head in front and head in second position as well. So we are getting one tail and one head. So that could be in this position or in this position. The probability of getting this and probability of getting sum of these two must be equal to 1 by 3. The question is, what is the probability of getting two heads and two tails if the coin is tossed 4 times? So first consider, let's suppose the probability of getting head is equal to x and probability of getting tail will be equal to 1 minus x because whole probability is equal to 1. If I consider the probability of head as x, the probability of getting tail will be 1 minus x. Now, if you see the first condition, the probability of getting one head and tail or tail and head will be equal to 1 by 3. So what is the probability of first head? That will be equal to x, and probability of tail that will be equal to 1 by x. And for the second, probability of tail is 1 minus x, and probability of head is x. This must be equal to 1 by 3. And if you proceed further, this will be x minus x square plus x minus x square is equal to 1 by 3. That will be 2 into or we can straightforward right from here, 2 into x into 1 minus x is equal to 1 by 3, or x into 1 minus x is equal to 1 by 6, right? Just hold in this position for a second. Now let's see what is happening further. What is the probability of getting 2 heads and 2 tails? You need to get 2 heads and 2 tails, right? 2 tails and 2 head. If the coin is tossed 4 times, so how can we do this? We can do this way: probability of tail into probability of tail into probability of head into probability of head, and for arrangement, this will be 4 factorial. They have 2 identical tails, 2 factorial, and 2 identical heads, 2 factorial. Now we know the probability of tail is how much? 1 minus x, 1 minus x, x into x into 4 factorial divided by 2 factorial into 2 factorial. So this will be x into 1 minus x whole square into 4 factorial into 4 into 3 into 2 factorial divided by 2 factorial into 2 factorial. This will cancel out, and from this further, this will be, we already know this thing, this will be 1 by 6 square into 6, which is equal to 1 by 6. The answer is to this is D. The only key point in this, you need to figure this thing out, and just moving further, this will make your way out. So whenever you see such question in which you are not getting any sort of straightforward answer, just try to be patient. You know this thing. Now you try to think that you can use this a bit further, and in the last you can use this in this term. Okay, try to solve this question, which has 3 greens. Green is 3, red is 2, and blue is 3. In a way, you will pick 5 from the back without replacement. What is the probability that of the 5 drawn balls, which picked 1 red, 2 greens, and 2 blues balls? Okay, so let's try to solve this first by probability method, and then we will see this using a combination. First of all, let's see, consider that he's picking 1 red first. So what is the probability of getting 1 red? So how much these are in total? These are 8, and probability of getting 1 red, that will be 2 by 8. And now probability of getting next one is green, 2 green, right? This one and this one. Okay, so first one green, how much? That will be 3. Now that will be 7 because this is without replacement. So 1 ball is already picked. Now out of 3, 1 is picked. Now we are left with 2, and total will become 6. And for the next 2 blues, first one, that will be 3 by 5, and next one will be 2 by 4. And this is only one arrangement in which we have red, green, green, blue, blue. We need to consider all of the arrangements. That's why we will multiply this with 5 factorial. The total arrangement divided by, we have 2 greens, 2 blues, and 1 red. So just proceed further, and in last you will left with 9 by 28. Right? This is the first method using the probability, in which I'm using this in the probability form. If I want to proceed using the combination method, using a combination form, how can I do that? So in total, I have 8, and from 8, I need to pick how much? I need to pick 5. So total outcomes will be equal to how much? 8C5. Now let's try to see the favorable outcomes. So if I want to pick one red, how can I do that? From 2, I need to pick 1. And I need to pick 2 greens out of 3. That will be 3C2. And I need to pick 2 blues out of 3. That will be 3C2 again. So just proceed further. Again, you will be left with 9/28, which is B. So either you can proceed with this combination or with the probability, you will land up with the right answer. Okay. These are very simple question. Let's proceed further and let's try to increase the difficulty level. Yeah, try to solve this question now. This question is tested in exam. This concept is tested in exam. Let's try to solve this question. A bag contain only blue and red balls. Some are blue balls and some are red balls. Okay. And the question is saying if one ball is drawn, the probability of selecting a blue ball. So that's mean the probability of selecting a blue balls out of total balls will be equal to 1/2. And if you proceed further, this will be 2B is equal to B plus R. That's mean B is equal to R. So they're equal number of blue balls and red balls. Next thing is if 2 balls are drawn randomly without replacement, the probability of selecting a blue ball first and then a red balls afterwards, right? Just see this thing then. So first of all, blue, then red ball will be equal to 5/18. And remember one thing, this is without replacement, right? So what is the probability of selecting a blue ball first? That will be B plus R. And the probability of selecting a red ball afterwards, that will be R over B plus R minus 1. Because this is without replacement, so there will the decrease of 1 in the total. That will be equal to 5/18. Now we already know this thing. At start, this thing is equal to 1/2. So 1/2 into R over B plus R minus 1 is equal to 5/18. This means this will equal to 9. And if you proceed further, R over B plus R minus 1 is equal to 5/9. And now the next thing is, we already know that the number of blues and number of red ball are equal. So that's mean R over 2R minus 1 is equal to 5/9. If you proceed further, 9R is equal to 10R minus 5. That's mean R is equal to 5. If R is equal to 5, so B is also 5. So till now we are sure that blue is equal to 5 and R is equal to 5. So in total, we have 10 balls right now. Then the question which is asked is that 2 balls are drawn randomly without replacement. Again, that without replacement. What is the probability of drawing a red ball given that the first ball drawn was blue? So this thing which is given that this is a condition probability is saying that first ball is blue, which is drawn already. Now, if I draw the red ball, the probability of drawing the red ball, that will be equal to what? Okay, so earlier, if I, at first, we have already picked the blue balls, the total is 10. Now, if I want to draw the red ball, the total will be 10 minus 1, R is equal to 5, so this will be 5/9. Because one ball which is already drawn is blue. And now I want to draw the red ball, draw the red ball. That will be 5 total and divided by total minus 1. This is total for red, and this is total as a whole minus 1. So this will be 5 by 9. Let's try this question and try to be quick. What's actually happening in this question? And okay. Certain experiment has only A, B, and C 3 outcomes. So that's mean the probability of getting A, probability of getting B, and probability of getting C must equal to 1. First thing. Next thing is if A and B are mutually exclusive. If two events are mutually exclusive, that means probability of first event and second event occurring at same time is equal to 0. Right? This is the second thing. The third thing is probability of A or B is equal to 0.7. And if I want to open this, that will be probability of A plus probability of B minus probability of A and D is equal to 0.7. We already know this is 0, and probability of A, probability of B is equal to 0.7. Now we know that probability of A plus probability of B plus probability of C is equal to 1. And if I substitute this in the first one, you will get the probability of C will be equal to 0.3. Let's call this third one. Okay. Now let's see further. If B and C are independent, as we know that if two events are independent, their AND probability will be the sum of their, will be the product of their probabilities. So probability of B and C will be equal to probability of B into probability of C, and probability of A and C is equal to 0.2. We need to find probability of B right now, and probability of C is already find out, which is 0.3. So probability of B will be equal to 0.2 by 0.3, which is 2 by 3. Now we know probability of C, probability of B. We can find the probability of A, and the whole sum equal to 1. So that's why probability of A plus 2 by 3 plus 0.3 is equal to 1, right? Okay, so probability of A will be equal to, just proceed, 1 minus 0.3 minus 2 by 3. So what is the answer? If you proceed further, you will get a 1 by 30 at last. So everyone got this? The only thing is that if events are mutually exclusive, their probability, combined probability of including A and B will be 0. If they are independent, then AND probability will be the product of their probabilities. Just use this concept. And the last thing is that the sum of probability is equal to 1. Just use these three main concepts and straightforward solve this question. The answer is 1 by 30. By visualization, by trying to use Venn diagram concept here. So we have three events, X, Y, and Z. And X is independent of Z. This is Y, this is Z. X is independent of both X and Z. And Y and Z are mutually exclusive. That's mean probability of Y and Z is equal to 0. Let's try to form a Venn diagram. Let's consider this event as X and this event as Y and this event as Z. I don't make any overlap between Y and Z because they are mutually exclusive and there is no overlap between them. And the question is saying that the probability of X is equal to 0.3, Y is equal to 0.35, and Z is equal to 0.4. 0.3, 0.35, and 0.4. Okay. Now, this thing is probability of X and Y, and this thing is probability of Z and X. And I told you earlier in the questions, it is stated that X is independent of Y and X is also independent of Z. As X and Y are independent, the probability of X and Y will be probability of X into probability of Y. So that will be 0.3 into 0.535. That is equal to how much? That is equal to 0.105, right? So this thing is equal to 0.105. If this thing is 0.105, what will be this thing? This will be 0.35 minus 0.105, which is equal to 0.245. So if you sum 0.245 and 0.105, this whole thing will be equal to 0.35. Now, if you talk about the Z and X, these two are also independent. So probability of Z and X will be 0.4 into 0.3, which is equal to 0.12. So this is equal to 0.12. So what will be this? This will be 0.4 minus 0.12, which is 0.28. And we are left with this portion only. This will be 0.3 minus 0.105 minus 0.12, which will be equal to how much? 0.075. So first of all, tell what the question is saying, the probability of none of these two events. So just add all of these and subtract this from 1. You will get none of these events. So 1 minus, now see 0.28 plus 0.12 plus 0.075 plus 0.105 and plus 0.245. Just add this. This is 1 minus 0.825 and this is equal to 0.175. That's why the answer, this is C. So if you are any confused how to proceed with this type of question, try to visualize this using the Venn diagram. That will make your case a bit easier. So everyone got this?
Yes.
Okay. Let's try one or two more questions. You can solve this. You can solve this as well. Yeah, try to solve this question. I will repeat this question by multiple ways. Again, by using the probability, straightforward, or using the combination. If anyone of you have seen the recent video, which is the second part of probability, I show a 4 method to solve a question, solve a probability question. You can use any of that, but it just stick to 2 methods right now. Okay, let's see how can we solve this using the first method, the probability method. But first of all, we need to see that what are the possible scenarios, what is it we ask in this question. If you see closely, we have a room filled with 7 people, in which 4 people have exactly 1 sibling and 3 have exactly 2 siblings. Let's call, to make things easier, A, B, C, D, E, F, and G. We have these 7 people in a room, and 4 people have exactly 1 sibling. So if I want to make this, I consider that A and B as a 1 pair, C and D as second pair, and E, F, G and third pair. That's mean that 4 people have exactly 1 sibling. These are 4 people, each of these are having a 1 sibling. A is sibling of B and B is sibling of A. C is sibling of D and D is a sibling of C. So these 4 have exactly 1 sibling. and 3 people have exactly 2 siblings. So E, F, G, each of these have exactly 2 siblings. E have F and G, F has E and G has E and F. So there are 3 pairs with 2 people, 2 and 3 people, right? Now the question is, if 2 individuals are selected from a room at random, we need to select 2 individuals. The question is, what is the probability that those 2 individuals are not siblings? So we need to pick any 2 person from different groups. We have 3 groups, right? From different groups, so that they won't be sibling, right? So this is what exactly question which is asked in this question. Now let's try to solve this using first method. Let's try to think this in terms of the combination. So how can we do this? Let's try to come up with cases. First case, that let's think, how can we do this? One way is, if you are picking one person with the from the first pair and one person from the second pair, one from first pair and one from second pair, right? And the second way is, if I'm picking one from the first pair and one from the third pair, third group, not pair because there are 3 people. And the last option is, if I pick one from the second pair and one from the third group. So we have 3 possible options to get the favorable outcome. Okay, let's try to see in the question. We have A, B as first pair, C, D as second, and E, F, G as third one. So what are the favorable outcomes first? So how can we do this? If I see the first scenario in which I am picking one from the first pair and one from the second pair. So how can I do this? If I'm picking one from the first pair and one from the second pair, if I'm picking one from the first pair and one from the third group, or if I'm picking one from the second pair and one from the last group, these are all favorable outcomes. These are 2 into 2 plus 2 into 3 plus 2 into 3. So this is 4 plus 6 plus 6, which is equal to 16. These are favorable outcomes. Total outcomes, we have 7 people, and from 7 we need to choose 2. So that will be 7 combination 2. 7 into 6 divided by 2, which is equal to 21. So the total probability of selecting 2 such that none of them are sibling, that will be 16 by 21. This is your first method. So everyone got this method?
Yes.
Okay, let's see the other method. And now if I consider that, again, A, B, C, D, E, F, G. This is first, second, and third. If I consider the inverse case, and if I consider that all, I'm just considering 2 which are already forming a pair. So restricted case, that will be, if I consider 2, if I pick 2 that are straightforward from the first pair, there will be 2C2. If those 2 are from second pair, again 2C2. If these 2 are from the last pair, last group, that is 3C2, and total outcome is 7C2, which is 21. So this is 1 plus 1 plus 3. This is 5. So overall probability will be total minus restricted case is 5 by 21, which is 21 minus 5 by 21, which is 16 by 21.
Yes. I follow this rule.
And the last one is, if you want me to go with the probability case as well, in case you want, or shall I move forward? You want me to solve this using the probability?
Yes.
Okay. So again, considering the A, B, C, D, E, F, G. This is the first, second, and third. Okay, so now let's see how can you move about. If I do this way, that if I pick first person from the third group, so how can we do this? 3 by 7. And if I pick the second person from first two groups, right? So that will be 4 by 6. And from first two groups, 1 or 2 group. The second thing, if I pick first person from these two groups, 4 by 6 into, and the second person from the last three groups, last third group, this is 4 by 7 and 3 by 6. And the next situation is, if I pick first person from the first group and second person from the second group, so that will be 2 by 7 into 2 by 6, and the vice versa. If I pick first person from the second group, this is 2 by 7 and into 2 by 6. If I pick from the first group, just add all of these, you will get 2 into 3 by 7 into 4 by 6 plus 2 into 2 by 7 into 2 by 6. So that will be 4 by 7 plus 4 by 21. This is 12 by 21 plus 4 by 21, which is 16 by 21. So you can either proceed with the probability portion, or you can proceed with the combination. You will straightforward get to the right answer.